getting cold, ready for the filming.
It's already rolling. I forgot the yellow action. Sorry. Let's get out of her seat. She comes.
We wait a couple of minutes. I guess it's not fair to start the questions when somebody is not here to listen.
Did you have any idea how to solve this first one on the open book? Okay. There.
They weren't bringing me down. They were about one of my
I was actually sitting in your seat.
on the right side.
Here, have a piece of paper.
Probably from that.
I don't even have a solo. We're good. Yeah, that's
Like 2 weeks.
yeah. Orgo is like a 5 days to a week.
Oh, enough walk to a lemonade.
I can cry Orgo. That's not really crying.
Or neither am I. What? I'm not ready either. No one's ready.
Yeah.
I looked at the practice test and it's
This is a dispersion?
because you gotta go up on safety talking about so.
Give me spread out. It's good. Yeah, I like to bring the whole library with me every single time I go to class.
I have a video of it.
Cool.
What are the units of town?
So I got really bitten up by.
Now I'm curious. Can I?
Yeah, go for it. Flip them upside down. The prompt is on the reverse.
Oh,
Do you have something? Do you have
I
something? Review of something?
Thank you.
okay. I can start taking questions.
Yeah, with Tommy Wiseau and Greg Contester, that video of it. You took that was a video? Yeah. Oh.
Why were you up on stage?
I asked them to my formal.
Important question. Will there be calculation of problems? Why the problem?
Oh no. What did he say?
Now, in the final, there may be some. In the final, we have like 3 parts. One part closed book, one part open book, and one part calculation. Just one problem. See if you can do the units.
No calculation problems.
But not for this test. I think Harun had his hand up. No? All right, questions?
Would you be able to give us the basic
No.
format of the test?
Yes.
Thank you. It'll be on paper.
No. Okay, the basic format of the test would be exactly like last year's.
Okay, so you said it would be more closed book, but it's not going to be more closed book. It's the same.
Yeah, I kind of changed my mind.
Okay.
So it's going to be probably closed book will be 60%, and open book will be. And it will not be as long. I don't expect you to take the first test. I kind of expect you to take a long time. because it was a lot of concepts and building equations and everything. This one is, I really think that, for example, did you see how this closed book was? You should be able to do it in the time prescribed, right? You cannot do it, it's not like you're gonna sit there and try to remember. If you don't remember the word dispersion, suspension, the equation, that's it. You know, you have to, so chances are, it's going to be like just give your test in after the time. Yes.
What's gonna be?
Oh, the exam will be next door, not here. We have both rooms, so if there is needs, we can use both rooms.
What kind of problems do we have in the open book? Okay.
Just like last year, very simple. Derivational.
Okay. That's
Yes, derivation, where, so even, so last year's test, right? The one on the left, have you done that problem now? Or should we do it? Okay, so one student last year, it really broke my heart for that person. Because he did not tell me during the test. He said, you know what? For the open book part, I brought everything that was pertaining to the second test. And you know that obviously you needed everything, right? In order to do the open book part. Have you done the open book part? You haven't tried it? You have tried it. What do you get? That's the answer.
for what?
For the first one.
Oh, I wrote it on loose leaf. I don't have it with me, but
It's very simple. I think it's like 5 or 6 over Reynolds.
oh,
Okay, so you bring for the open book part, definitely you have to have like a book, you have to have the notes. And that person did not tell me during the exam, right? After the exam, because I would have given him the notes. She had told me during the exam. He or she. Okay. So the open book part. The levy. The water goes up, and then overflows, right? And I said derive an expression similar to the expression for the tube flow, but for this. So, now, I don't think there was anybody who saw it right away, but people did get the right answer. They spent like half an hour with this problem to get it. But of course, if they had seen it and if they understood it, they did it like in what, 5 minutes, something like that. What I'm saying is the open book part could be done in, because I have an idea now what it's going to look like. Could be done in 10 minutes, 15 minutes, half an hour. If you don't get it by 45 minutes, 1 hour again, your chances are very small. Because you will have everything open book. Because look at this one, right? That I gave last year. It's going to be, I'm not saying, of course it's not going to be the same problem, okay? You should be able to do it. Do you understand what this is asking or not? Well, get it out, get what I gave you the exam, right? Think. I made a point to bring a lot of stuff that I may not have brought that. No, I haven't. I have to forward it from you. Can you share it? Alright, so exam 2, open book part, 40 minutes. Consider the event of the water of a river rising and overflowing on the river's levees. A hypothetical case would be the Mississippi and its levees, like the river road and behind the Audubon Zoo. The engineering task is to develop a predictive tool for shear forces exerted by the flowing water on the levels, which can be modeled as inclined planes. As a first step, you're hired to develop an expression for friction factor in the laminar flow region, right? So far, do you understand? Analogous to what we found, the circular tube equation 2.107, which was some 12 over Reynolds number, something like that, 16, I think. 16 over Reynolds number, I think. Okay? Please use all information equations that are available to you. Okay, so if I cannot believe that I did not bring also the do you have the notes from the first part of the semester? No, the handout with about the flow through a tube, Hagen-Poiseuille flow, and all that. What I handed out. Yes. Thank you. Let's borrow it forcefully. All right. Oh, here you have it. These are the pages. She has them marked. Okay. So what I'm looking here from Gabriel's notes is there is an equation for the average velocity. It's derived for you. So the average velocity is V is equal to rho g delta square cosine beta over 3 nu. That's the average velocity of flow on an inclined plane. Okay, if you've never seen this and everything, you know, there's not much anybody can do for you or yourselves. Okay? So this is listed. On 2 pages before, Gabrielle will tell me what she has, because I like that.
Oh.
She has highlighted the shear. Done. In other words, you don't have to be able to do it, just have the answer, right? The shear. It says tau xc is equal to rho gx cosine beta. Now, the thickness of the film was small delta. And cosine beta is this angle. This angle they call beta. It doesn't matter if you chose a different angle, it will be from the side. No? No, that's not. Yeah, the angle is this one. This one is big. All right? Now, what's the definition of the finding friction factor K? That is, look, I mean, this is open book. Now, okay, so it says tau over 1/2 rho v squared, right? Where v is the average velocity, but it's tau sub s on the surface, which means that if I want to use the velocity from here and the tau from here on the surface, x is equal to what? Delta, right? Because that's delta. Okay, so now I also know that a Reynolds number is defined as rho V times some characteristic distance. For our tube it was R, or D, the diameter, right? In this case it's going to be delta. So this is going to be my Reynolds number. So what is the smartest way of using these two equations? The smartest way of using these two equations is to write the tau s, because the tau s is going to be this, rho g delta cosine theta, and then on the bottom 1/2 rho, but we have v squared. But we want a v, remember, the Reynolds number is rho times delta times v, right? So we want to leave one of the v's and substitute for one of the v's from this equation. Rho g delta squared cosine beta over 3 nu. And now we have the answer. Because this rho g will cancel that, this delta will cancel this square, cosine cancel the cosine, and we simply have 6 over Reynolds number defined there, right? In other words, if somebody really saw it, they could do it in 5 minutes. I did not expect people to see it, and I don't remember anybody like just boom, seeing it. But if you cannot do it after 20 minutes, 25 minutes, your chances of seeing this diminish, right?
Would you be able to explain how you substituted delta for d as well as x for delta? How did you put
Yes.
the delta in both those
Yes.
places?
So in an implied plane, x is 0 here, and x is 0 to delta here. So tau sub s is the tau of the surface. So since x is equal to delta there, that's tau sub s.
Okay.
Right? That's the first. Now, how do you substitute delta for d? Well, the Reynolds number is going to be some characteristic number, some characteristic distance, right? For the d. Well, what do we have here? Like, what is the equivalent of diameter for a film? It's the thickness.
Okay.
The length is not.
Right.
Because the length can be longer and longer. It doesn't make any difference in the problem.
Okay.
Yes.
Just to be clear, that the test goes through the material that we learned Thursday, correct?
Yes. Not only, but the material that we did Thursday will certainly be on the test. That's a giveaway. Right. Do you understand this problem? Now, the other one that I did was very simple. Actually, a lot of people, pretty much everybody got the next one. And I don't think, if you have not tried it, I don't want to. Has everybody done the second one? Or tried to do it and could not get it? So I'm not gonna do it because it's the same thing that, you remember that thing that we had done with the Reynolds number times square root of f? It's very simple. Yeah.
Can you like just email us the answer and we open it up when we do it? Oh.
I mean, I can, but I will not.
Okay.
It's wrong English, right? It's wrong English answer to say, no, I can't. It's no, I will not. Yes.
Are we expected to memorize like all the Reynolds numbers that like laminar flow and turbulent flow fall under? Because there's several different ones for each.
The Reynolds number does not depend on turbulence. It's the correlation that depends on Reynolds number. What is that we use? The Reynolds number is the Reynolds number. Now, the different Reynolds numbers that we have seen in different situations pertain to what? To flow through tube. That was rho dV over mu. Then we had one for the sphere that was falling, and that was also rho dV over mu, so it just happened to be the same. D was d sub p, diameter of the particle. And then we had the Reynolds number of flow through porous medium. That was different. It had the epsilon, remember? And I asked you in a quiz, and chances are again, I think I asked it in the exam, and I may ask it again. So these are the Reynolds numbers you need to remember, right? Of course, hydraulic diameter, so that you can derive the Reynolds number A. Okay, so that was the this is Will's exam. He's done most of it here. But do you have questions in like on the exam, mostly what I meant? Because everything is in your notes. So let me repeat, because I have not printed the exam out, but I have it in my mind. I'm going to do it after this. The exam is going to be very, very similar format to this. 2 problems for open book, which I guess I was giving them 40 minutes last time. It will be the same this time. 40 minutes. And the closed book 50 minutes. So just like last year's. In a way you're luckier than last year's because you have some kind of format. I don't think I had given them a format last year. I had told them how it was going to be, but I have not given it to them. The equation is falling with very slow velocity. That's creeping flow, right? Less than 1. Less than 1. And for the case of flow through a tube, I think it's less than 2100. Then, yeah.
What's the agitation system that consists of a tube with non-moving blades?
Okay, that's a static or motionless mixer. In other words, you have some helical ribbon inside a tube, and as you are flowing stuff, that helical ribbon forces the stuff to mix. So motionless or static mixer. Okay, this I discussed in class, right? And I will discuss it again. You remember when we said if you have like if this is the room and you have water and it starts exiting, like through a tank, from the bottom of a tank. As it enters here in this pipe, at first the profile is going to be very sharp. It will not be developed profile, which means that on the surface of the tube, of the opening, the derivative of the velocity is infinity, theoretically, right at c is equal to 0, which means that actually it's the opposite. The rate of shear on the surface decreases as you go, so it's false. That one is false. Yes.
Never mind. I think. Wait, actually, no, I asked it. Why is it that the shear stress is infinity? Is that because of the velocity?
Okay, because the shear stress is negative mu dv dr. Okay? So dv dr, if right when it enters, it has a velocity profile that is a rectangular profile. If you plot this velocity versus r, it looks like this. This would be V maximum, and this would be a sharp decline to the radius. So what is dVdr right here at small r is equal to capital R? Infinity. Now you remember when you have like a function, when a function does stuff like goes like this or like that. At that point, this is infinity. In that case, it's negative infinity, but it's infinity. The absolute value. And it's negative infinity, right? It's negative infinity, but then we have a negative sign. So negative infinity times negative is positive infinite shear on the surface. But that only lasts zero length, right? That's only at the very entrance, at that one circle, at that first circle of tube at the entrance. Other questions? Yes.
Will we have to know the difference between a paddle agitator and a turbine agitator?
If you see a picture, you should be able to tell which one is what. Yes. Yes. The answer is yes.
How can you tell the difference?
Well, a turbine is more like okay, I see. Okay, so paddle agitator reaches all the way to the end of the container. In other words, if this is your container, your tank, you have a paddle agitator. The paddle agitator is going to reach all the way to the end. It will almost be scraping. It will not be touching the wall, but it will almost be touching the wall. So if something is shown like this, that's a paddle. If it is shown like this, and I'm asking you, is this a turbine or a paddle? If it goes until there, chances are that this is going to be a turbine. Now, can you misread a drawing, yes, I'm not gonna give that question. But you're supposed to be able to tell, right? That the paddle is something that moves like a paddle and almost scrapes. So it doesn't want stuff to build on the wall. It's for much thicker fluids, for pastes, that you use that. Much thicker liquids, liquid suspensions, slides, so, yes.
What are the units of permeability?
Okay, let's see. Oh, okay. Actually, what I wanted is Darcy's, because you can get them from the equation, but it's Darcy, okay. They refer to them as Darcy's even though they have also other, but that's the answer. Darcy's. Darcy's spelled with a Y, like you correctly spelled it, not with an I-E, right? That's a name. I think so, I think that's true, but it's also in the book, yeah, you can develop that, right? I think it's that. Isn't that true? Maybe it's not true, let me see. I don't remember, I think it's false. Is it D1 minus D2 or over 2 or just D1 minus D2 period?
Over 4.
The hydraulic radius.
Yeah, E over 4.
Sure. Whatever. I mean, it's in. I don't remember those things. I mean, I can derive it if you have doubts. Just derive it, right? That's how you spend a few more minutes in the exam. Nice.
E over 3. Wait, oh. Is that graph?
Oh, I did not. I did not discuss this, right? So okay. So I'm telling you, take these two pictures. These two pictures. Take them out.
Yes.
I mean, they are in the book, but I can tell you, I will not ask those.
So that's for the equipment, class.
Yes. I will not ask you for equipment that they have not drawn in class. Understand? I think I gave you a handout with those.
No.
Yes, I have.
Helical screw,
I found it in textbook.
you found it in the textbook.
This last four are all in one chapter.
Okay, so take even these ones, the helical, the double helical ribbon, helical screw, take them out. With pleasure.
These two?
Yeah, but maybe you did not know. That day I remember bronze color.
Yeah.
Yeah, with the screen, so I only get a few, so some people got it, some people no. So yeah, only the equipment that I discussed was done.
Can you tell me, like, this equation?
Yes.
What's it for?
Oh, okay, that's a good question. So he's asking a question about filtration, right? And he said, what is that equation for?
it.
I think
Right?
We're not really actually.
it was last time when we discussed it, I'm pretty sure. It was constant pressure filtration. Constant pressure filtration. Where we found that time needed to process a certain amount of volume of slurry, and again, the assumption here is made that if you have this, may I? It's too tempting not to use this one. If this is a slurry and you filter it, the volume of the filtrate is going to be the same as the slurry. Now, that's an assumption, right? It's going to be a little bit smaller, but it's an assumption. It was used in that derivation that we did last time. And after we did all that derivation, I think there was here a Kp divided by 2 times V plus B. Is that the equation? Yes. So, V is the total filtrate, or the amount of slurry that we have processed, the volume, at time t. The nice thing about this equation, what I said, important part, is that writing the equation this way, because before we wrote it this way, this V was V squared here, and then it was multiplying B. But this is a trick that is done a lot of the times in engineering, not just chemical engineering, even electrical engineers. When they want to use a certain equation in a form that the left-hand side is linear with respect to the right-hand side, so that they can use experimental data to fit parameters. And what I said is, if you run now an experiment at different times, and you collect a certain volume for a certain time that corresponds to T over V, and then another one, and then another one, and then another one, if this is linear, you're going to get a straight line. From 4 experimental data, you can plot a line, a straight line. From this line, you have a slope, which is this. And you have an intercept, which is this. So this is going to be your B, and the slope would be Kp over 2. Once you have these two, then for any amount of, if you process more volume or less than these numbers, in other words, if you process this amount, you can find T over V, and from T over V you find T, because the question was, the engineering question was, if we want to process so much, how much time do we have to keep filtering at constant pressure? So that was the answer. Okay? I mean, that was the reasoning behind doing that.
We have to memorize what exact K and B was.
No. You don't have to memorize K sub P and B, but you do have to know how this came about. I may not ask the entire derivation, but I may ask part of it from the derivation. Remember, there was pop, 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 there were different things. Remember that mass balance that we wrote? And then there was another equation, dV times A over dt.
Over A.
D, velocity, right? A over dt, that was like the volumetric flow rate, and then we inverted it. Okay, so you have to know those things. You absolutely have to go to know that, because I'm telling you, something from there is going to be on the exam tomorrow. Yes.
Can you review how you non-dimensionalized, it's friction factor times Reynolds number squared versus just friction factor? And like, what type of scenario should it be like our like trigger to be like, oh, I should do that?
Okay, so the reason we did that because we had to solve for velocity. And velocity was, or flow rate. We were talking at the time for flow through a tube. Turbulent flow through a tube. And when we have our F versus Reynolds number, log, remember this is a log graph. If you are in this region, one engineering question was, if you know flow rate, which means you know V, right? You understand this, right? If you know flow rate, you also know V, because the average velocity is the velocity divided by the cross-sectional area. If you have that, if you know this, then you know the Reynolds number, which is rho dV over mu, and you go up this way and you find your friction factor. The friction factor has embedded delta P and V. But if you don't know the velocity, but you know the delta P and you want to find the velocity or the flow rate, then you have to do trial and error. So in order to avoid now having to do that trial and error, you construct that other diagram of two numbers that do not depend on velocity. No, it's not that they don't depend, because the Reynolds number does depend on velocity. You plot the Reynolds number versus Reynolds number times square root of F, because the F has velocity square over, divided by velocity square. So you get rid of the velocity. So once you construct that, then you can go and find that number for your problem. And so if you have Reynolds number times square root of F here versus Reynolds number, and you can construct this graph no matter what, then for a certain delta P, the Reynolds number times friction factor to the square to the half power does not depend on the velocity. So you can go this way, rid of this, and now the number that you have is rho dV over mu. So you find the velocity. Okay.
But we'd have to just construct that original graph with real data, or would we are we just plugging in?
Yeah.
Whatever.
So So for the exam, there would be no numerical calculations. Okay? You don't have to have a graph in order to solve for a problem. For this exam, anyway. I'm not sure about the final. Other questions?
So this has a little bit to do with number 2 on exam 2, but like
All right.
it's not just asking the answer. So I'm guessing that one of the
Yeah,
formulas you use is the Reynolds number for agitators.
right.
What would be the other one?
What's that?
So you need to cancel out the n in the Reynolds number for agitators. In
Yeah.
order to
So, I don't have my notes. Can I see the thing? Yeah. All right. So it says you are given all geometric specifications data. You have everything, and now remember that the power number you used it. Power number versus Reynolds number. Is that power number or time? Time, right? There was a time. The time that we need, I think, we can plot it this. F sub t versus Reynolds number, and F sub t I was trying to bring everything here, but okay, I actually have this. F sub t, I wrote it, I think, for you. F sub t is equal to t sub t, the time for mixing, that you need to mix something, times n dA to the 2/3 g to 1/6 d sub a h to the 1/2 on the bottom dt to the 3/2. Where's that?
In the numerator, and the last DA is also to the one, the last one.
Okay, to the 1/2. Well, it doesn't matter right now because this is open book. You don't use this, right? And then tell me, oh, that's what you wrote on the book. You use what's in the book. Okay? Now, the important thing, you want to solve for this. But the Reynolds number also has that, doesn't it? For mixing. Because the Reynolds number for mixing is defined as d sub a squared n rho over nu. So you have n both here and here, Alex, right? So you use trial and error. Now, if you want to avoid trial and error, you have to create a new group that is a product of this, of a function of this, and this, so as to eliminate n. So it's obvious, right, what you should do. You have to, because n is on the top of both of them, you have to divide really one by the other, but account for these 2/3. You see that? That if you want to create a new dimension, those are both dimensionless numbers. So if you take f of t, f sub t, to 1 over f sub t to which power in order to make it linear with n? To the 3/2, right? To the 3/2 times Reynolds number, then this new group is not going to be a function of n. So this was also a 5-minute problem. Alex. Really? Right?
Yes.
Because, so you said the new number will have to be a Reynolds number divided by f sub t to the 3/2. And you plot this versus, or you plot Reynolds number versus this. So you create a new plot, and then this group here, you can evaluate it for the given problem that I gave because you have all the properties. You have d, you have h, you have t sub t, and etc. You have everything. That is yours again, right? Who did I take it from? Okay. And then in less than 150 words. So this really, again. And it will be again tomorrow the same way. If you see it, you can do it in 10 minutes. If you don't see it, but you have understood everything, you will be able to do it in 40 minutes. Perfect. Right?
For the closed book, I'm assuming we wouldn't have to memorize an equation like that, right?
No.
Okay, so which
No.
which equation should we memorize and which one shouldn't we?
Okay, important equations that are short. Okay, so should you memorize the Bernoulli equation? Yeah. It's so simple. So simple. P plus P over O, right? Plus
So simple.
1/2 V squared plus GZ. I mean, so it's constant. Yeah, of course you have to memorize the Bernoulli equation. Yeah.
What is that constant?
Which constant?
Like, in,
Oh, it means that 1 is equal to 2. It means it's constant, and this being constant. So she's asking, this equation being constant, it means that this is equal to C2G, the right hand side. Yeah, it's the same. It's the same before as after.
okay, thank you.
It stays constant. Before and after, it's the same. So actually, she's right. I miswrote that. I'm sorry. I just realized that. So it's not Z1. I should not have written Z1. I should have written Z, G plus 1/2 V squared plus, like I said before, P over O is constant. Which means if you put 1 subscript, that whole expression is the same as when you put subscript 2. Been doing it. You've noticed? Because I tried to listen to her. I missed. You have? You must be very much attracted to this, the two of you. You could have said.
Last year,
Okay, so the test is going to be in the other room because there is a beeping noise from the
I've never noticed it, maybe I just can't hear them.
No, I hear
Okay, do you have any other questions? Yes, because I want to let you go study.
So
Let me go right and finish the exam.
So short equations, so like not a whole lot of.
Yeah, listen.
Okay.
Is it possible that I will ask you to write the overall mechanical energy balance equation? The answer is also yes.
Okay.
So that's a long equation, but it's something
Makes sense.
it's like a reasonable equation. This would not be a reasonable in class, right?
Right.
If a professor comes and asks that question to students, I would not support populating his class or her class, right? So I would not. I mean, what's the point asking that? But asking an energy balance equation is very important. Yes.
Okay, so for that, the mass balance equation that you gave us for that, like,
Energy.
this one? This equation needs to be.
Oh, that's mass balance. Yeah. That's mass balance.
Okay, so,
Yes, you need not to derive it. I know that you should memorize it, but this is a common sense equation. You need to know how to do it. So if you want to memorize it, that's fine. But okay, so she asked a very pertinent thing that probably will be in the exam tomorrow. That equation that says the length of the K times A times 1 minus epsilon times rho P is equal to C sub S V plus do you need to memorize that equation? The answer is this equation. We wrote it last time for filtration. LA 1 minus epsilon rho sub B is equal to C sub S B plus CS Q LA. Remember that equation? Okay. Now, memorizing that equation and not knowing it, not being able to see it, does you injustice. So if I told you write this equation or derive this equation and you wrote it and you did not derive it, yeah, you would get the credit, right? But it's more important to understand it. Okay? Do you understand it?
No, that's what I want you to
Okay.
Like,
Oh.
I don't understand. Because we use that equation to get to the one you
Right.
have box.
Right.
Yes, can you go over that?
Right. Let me see if I have the notes that I used last time so that I can give you this email.
Concentration of the solid.
Thankfully, I have the notes that I used last time.
No,
Now, are there other questions? Because I don't want to keep people who know this, or you want to hear it. Why don't you? Yeah, it's a good idea.
Okay.
Okay, so remember from the leaf that had the filter cake around it, we took very small parts, kind of very tiny. Then we magnified it. So this is L, the length of the cake. This is a certain area, overall area of the cake, which is A, cross-sectional area. And then we have the medium, filter medium, and then we pick up the filtrate on the right hand side.
15, 18 seconds.
And I think I drew purposely some of the pores. Where your material travels, and then it travels through different pores in the medium to go there. And then I drew another pore that was tortuous and went around this way, maybe a different way, and went here, and then there was, of course, a different kind of pore through the medium. So, what I said is that at any given time, I don't think she's seeing me over there. Turn this way. Yes. At any time, at any given time t, the amount of material that has formed as K has a volume L times A. Do you get that part? If you multiply that L times K by 1 minus epsilon, you get actually the real volume, because that's, you eliminate the space of the voids. Right? Because the voids are going to be these ones. What I have drawn here are pretty much the voids, and there are many like that. Okay? And then when you multiply this by rho sub B, you get the total mass that has been accumulated at some time t on the filter as filter K. Now this is equal to C sub S times V And what I drew was a collection bucket where you were collecting your V as a function of time. Because your filtrate comes this way. And we're assuming that this is the same, right? So now, this filtrate that has been collected, this volume V, if we multiply by the concentration that the slurry had, so the slurry has a concentration C sub S, and the C sub S is the grams of solids per cc. In other words, it's the mass concentration. And seemingly, that would be adequate to stop here. But actually, we also want to account for the little particles of solid that are inside the pores, in the void. And what is that? The volume of all the void is epsilon LA. This is the volume of the solids. This is the volume of the voids. So those voids have also suspended particles. So we multiply by the C sub S. And now we have a total mass balance. This equation is very important. This equation in some form will be tomorrow in the exam.
So that shouldn't be a Q over there, then that should be an epsilon.
What's that?
That shouldn't be a Q over there.
Oh, yeah.
Okay.
That was curved. I think I was copying somebody's notes, right? You have Q or epsilon? Epsilon, I read as Q. So
Okay.
don't do that in the exam. Write it clearly. It says. Other questions? Alexis.
So like the Ergo equation,
What?
we need to write down the law.
Which long equation?
Bergen.
Ergon equation? No, you don't remember.
Or the other one that went with it. Yeah, the Blake Cosney.
The Ergon equation or the Berke-Palmer equation, or you don't need to remember it. You need to recognize it.
Blake Cosney.
Blake Cosney, yeah. You need to recognize those equations. Did I say last year to write them out? I hope not, right?
What is the Burke-Palmer?
The Berke-Palmer is the one. Berke-Palmer is in Ergon equation. You have the first one, which is Blake Cosney for laminar flow, and then you have the one for turbulent flow, which is Berke-Palmer. That's turbulent flow. Wait.
Okay.
The one that is for turbulent flow is Berke-Palmer.
Okay.
And the summation of the two makes the Ergon equation. So that's correct.
Okay.
This statement.
So summation of these two is there.
Yeah.
Okay.
Yeah, I mean, the English may not be perfect. Yes. What? A patch bed, of course, can be horizontal. What cannot be horizontal? Fluidized. Fluidized cannot be horizontal. Patch bed can be horizontal.
Wait, sorry, I have a question. So, in class, you told us that this with the 1.75 was the ergon. and then
No.
if you added the
No,
Lake
no, no, no,
Cosany
no,
and the
no,
Ergun.
no, no. The whole thing is Ergun. It's
Okay.
wrong.
Okay, because that's what.
Yeah, check the book.
Okay.
This is wrong.
Okay.
I might have misspoken, or you might, written it there instead of here.
Okay. So you
The whole thing is the
whole thing. Okay. So this is the
first one.
this is the Burke
Blake
Plummer.
Cousin.
The
Blake
this is
Cousin.
the Blake, right?
Same thing. Oh, I'm sorry. I was not seeing down here.
Okay.
I was not seeing down here what you had. So this is the Blake Cousin, and this is the Burke Plummer.
Okay. Great. Thank you.
So it's,
Okay. This
Yeah.
one's the Burke.
Yeah, Bertie Plummer.
Okay. Got it.
Yeah.
like you'll be there.
Okay. Good luck tomorrow. What time tomorrow? 4. Go directly to next room.